Well, hello everyone, and welcome back to Adrian's Digital Basement. This is part 2 in the NEC APC, or Advanced Personal Computer series. If you haven't watched part 1 yet, I recommend you pause this video and go watch that first, because this is a continuation where I left off. In part 1, I got this machine working by simply taking it apart and replacing the power switch, which is right down here. It had gotten some kind of a physical impact before I got this machine, which broke the power switch, and that was actually all that was wrong with this. In this video, what I'd like to do is explore the software that came on the big stack of disks I got with this thing, but also try to get software running on this thing, because this is not only a CPM 86 machine, but it's also an MS-DOS machine. So I want to see if I can get any MS-DOS software that was designed for the IBM PC actually working on this thing. So without further ado, let's get right to it. Alright, first I wanted to start this video off with something I think is really cool for a machine of this vintage, which is around circa 1982. This machine itself being made sometime early in 1983. I'm loaded up into CPM 86 version 1.1. Currently this is displaying all of the characters that are built into the ROM chip, but I wanted to show the command POW, and what happens when you run that is this is the soft power off command that this machine supports. Reading the help file, it talks about the fact that you might want to use this in your script. So if you have this computer doing some heavy processing through the night, you can have it then just turn itself off when it's done. So it's not sitting there running all night. And there it is. The machine just turned itself off. Now the interesting thing is you can see there that the power switch is still on, but there's a relay on that power supply module that did cut power to the entire rest of the machine. The power switch itself is connected directly to the live and neutral coming from the power cord, which is why the LED is still on, or it's probably a little neon lamp in there, is still running. To get the machine working again, you have to turn off the power on the master power switch, and then we turn it back on. And I still don't really know why the power switch doesn't light up right away when the machine turns on. I don't think it's software controlled or anything like that, because like I said, it is connected directly to the power cord, but it does start up eventually. So I don't know what's going on there. Once it goes though, once it turns on, it does stay running. But there the machine is fully booted up. I even set the current date. It is October 30th, 2022 right now. I have no idea if this is Y2K compatible. The date command, at least for CPM, takes the year as just a 2-digit date. There's also the time, which seems to be correct, and I've had the computer off for a good while, and it is recalled or remembered while the power's off. So that battery I connected up, the CR2032, is absolutely working. In part 1 of this machine, people pointed out that I mentioned that it was an MS-DOS machine, but I only showed it booting CPM 86. And actually that happened because I had recorded more footage for that first video, but then the video got really long and I decided to cut the video where I did, which unfortunately meant that I only booted up CPM on this machine. But I have the original MS-DOS boot disk right here from NEC. As you can see, it is MS-DOS 2.11 on an 8-inch floppy disk. So this would have been one of the disks that came with this machine. So why don't we give this a try right now in this machine. So let's take a look at the boot process on this computer from the start. So you have to move the keyboard to flip on the machine, and there the LED came on, or the power light. Took a little bit less time than it had been in the past. I don't have the disk in the drive, so we're going to wait for the CRT to warm up and then we'll take a look at the message that shows up. All we see right from the start is 2 square brackets and an asterisk, and it just sits there indefinitely with that on the screen. If I put the disk in the drive now and I latch it, it will immediately start booting. This changes to an LOD, and something else showed up there, and then it went away very quickly. But there we have it, MS-DOS 2.11, copyright 1981, 82, and 83, Microsoft Corporation. Current date is 3/17/2081. So let's put in the correct date, which was 11/02, 2022. Let's reboot this computer and see if it retains the date properly in both the top status bar and in MS-DOS. I figured out that to reboot this machine, and I have to tell you, it took me a while to figure this out because I read through the manuals on this and I couldn't find any reference to it. You push function control and you push break stop, and that does a soft reboot on this computer. All right, well, the date is totally wrong now, 12/31/2006, and up here is Wednesday, January 8th, less than 0 is the year. That didn't work. It's funny that when I set the date, though, you hit enter. Oh, now it didn't set that properly. It changed it. Let's try setting the date again, but I'll set it to a different year. We'll set it to 1989. I'm sure that's going to work. There we go, Thursday, 1989. Let me touch on briefly the LEDs that are on these two drives. So 8-inch disk drives, the spindle runs all the time the disk is inserted in there. It doesn't spin up as you go to access it like it does on a 5¼ inch drive. So what the two bottom LEDs on the disk drives mean is that a disk is inserted and it is currently spinning. And then of course the top LEDs are the access lights. So let me insert another disk in here. And it's interesting, actually, as soon as I push that in, I could hear the motor spin up. So I guess the motor is actually spinning now, but the light doesn't come on until I actually latch the drive. And now that is on. So let me access the second drive here. And there the light comes on. And actually this disk, I think, is formatted for CP/M, so that's not gonna work. But I'm gonna hit the reboot sequence and we'll watch the boot up go. And you see this, as it loads, we hear lots of clunking. That's both the head moving around on the disk, but also the head can load and unload. On 8-inch drives, because they're spinning all the time, to not wear out the physical media, what happens is their read-write heads can be unloaded from the disk, which means there's a solenoid that lifts them away from the disk surface. That just prevents that additional wear of the head riding around the disk potentially indefinitely, because you might have this computer on for days or 24/7, and you just don't want your disks to be worn away by the head spinning on them. These two drives have a very nice eject mechanism, so when you release the latch, the disk just slides out very nicely. And then you push them in, they have to click in, and you latch them, and there we go. Both drives are ready to go. So MS-DOS, as you would expect, is extremely similar to how it is on the PC. Right here, there's a directory called WP, and yes, I said directory because we can do CD WP, and now we're in a different directory on this disk. Now, in this directory appears to be a copy of WordStar for this machine, and if we run it, it's going to be the very normal WordStar that you're very familiar with. There it is, WordStar 3.3 for the 8088, and it said it's specifically for the NEC APC. What we can also do on this version of DOS is $P, $G, and that gives us the directory that we're currently in. One command I noticed in here is color.exe, and if we run that, this allows us to set a color. Now, remember that this computer can come in either monochrome version, which is what I have here, and a color version, which actually has a color CRT. The display adapter in here supports color, it's just there's a jumper set to basically force it to monochrome. Now you can see some of the colors are brighter than others, and the text on the screen is a little bit dim, so let's change it to 7 just so we get a little bit brighter text in MS-DOS. Now you might be interested to know how much space is actually on these disks, and it looks like this disk actually has a bad sector, but I am not gonna do anything with it there, or not a bad sector, but a lost chain. So here we go, there's the total memory, 128K, as we already know, and then there you can see the total disk space, 1,250,000 bytes. I think it comes out to about 1.15 megabytes on each one of these double-sided disks. Think about that. In 1982, 1983, when you got this computer, compared to your friends with the IBM PC, you had so much more space available, even without having a hard drive. Looking at the other commands on this DOS disk, it's all the pretty similar stuff for DOS 3.3. Disk copy, edlin, check disk, debug is on here, sort. But there are a few other interesting things. There's one command here called CHR, which actually allows you to edit the character set that's in the auxiliary RAM-based character ROM on this character RAM, I think I should say. So let's do it. We're gonna update. There's a file here, auxcg.chr, which I think is a character set. And And we're going to output to adrian.chr. Now loading. And then we're going to say start. And there it is. There is the character font editor for this machine. I guess it's just included on the DOS disk. We can use the arrow keys on the keyboard, and we can, draw lines and stuff. And there's a little bit of static. And watch, if I erase this R here, then that's the character we have now. And it actually has a demonstration of what that character is right here. That is the character. That's what I've drawn right here, and that was how it would render in the normal resolution of the screen. I think if I hit the enter key, it will go to the next character, which happens to be a happy face. Okay, that's pretty cool. And there's a trademark symbol and a down arrow, and you get the idea. I think if we hit E for end yes or no, we're going to say yes. Create Adrian file, we're going to say yes. And I think it should save what we just edited to adrian.chr, and there it is, has been configured. So there's a couple commands we can run. One is disp, and I think this is showing the auxiliary character set right now, but the Adrian one is not currently loaded. So this is what's in the RAM right now on the video board, which you can see is just mostly these lines. And there's another display command, disp1, which should give us the same thing, but now we're looking at the built-in ROM-based character set, which is called ASCII.chr. And all of these can be typed on the keyboard by using these latching graph 1 and 2 buttons. So if we push graph 1 and I type down here, I'm going to be getting some of these special characters, which I guess are those right there. Here's a command called visual that was on the disk that just sort of demonstrates the various characters and font capabilities of this computer. It doesn't appear to be rendering quite perfectly, because I've seen some other programs where it can draw boxes around text, and of course you have flashing text and inverse text, and the font rendering on this machine is extremely clear and very high resolution. We determined the resolution is 640 by 475, which for its time was really quite amazing, and it's not interlaced or anything, so there's no visible flicker. Now we do know it also runs at 41 Hertz refresh rate, which is very slow, but it looks really good because of this long persistence phosphor that's on here. Just poking around with some of the other commands that are on here, there's CRT type, which just tells us that it is a monochrome and non-graphic display. We need a second display board to have any graphics capability on here. There's a little 95-byte music test program, which just plays some scales. There's some other programs on the CP/M disk that also plays a little bit of music, but nothing I've heard seems to demonstrate the volume control, like attack and decay, that I think this sound chip has in it. So everything just sounds pretty much like a beep speaker. You may notice as well, this disk seems to have Microsoft Assembler on it, and there's a linker right there, so you can assemble your own programs if you're good at x86 assembly. This machine also supports a hard drive, so there's a couple utilities on here for initializing and mounting the hard drive as an external device, and I do not think it actually supports booting. It's only for adding as additional storage once you boot it off a floppy disk. And of course, since this is Alps, I'm sure it's SKCC switches there, so very similar to what's on like the original Macintosh keyboards or SKCC. Has a very nice, it's a linear key switch. Very, very nice feel. As old as this computer is, I didn't really do any cleaning on the keyboard. I mean, it had a little bit of grime on the tops of the keys, but I didn't clean, deep down. I didn't take it apart or anything. And it all seems to work. And this keyboard feels really nice. And I'm typing off to the side as well. So the APC computer came with this rather sizable stack of 8-inch discs. And let's take a look at least at the labels on these to try to figure out which are MS-DOS, which are CP/M86, and then start looking through them. Also, one thing to remember is I am making this video right now before the first video has gone live. I actually fully anticipate that viewers are going to put useful information in the comments section on the first video, pointing me to resources or maybe disk images or other software that I can get for this computer. But up until this point, I am still operating off the minimal amount of knowledge that I have after making the first video. All right, so this is the floppy disk that I was just booting the system off of. This is CP/M86, and someone wrote original on here, and there's a couple dates written, and it says basic backup. Now, before I move on with the rest of these disks, I want to talk about one thing about 8-inch disk, which is something that's a little bit different that people may not be used to. 8-inch discs, unlike 5 1/4-inch discs, actually are physically different depending on if they are single-sided or double-sided. If we talk about the anatomy of a floppy disk, this black part here is the carrier that basically is holding the magnetic media inside of it. The magnetic media is this part here that's exposed through the spindle opening and also down here where the head reads the disk. But there's a hole right here inside the outside carrier that allows for an index hole to be read by a sensor of the disk drive. If I grab a 5 1/4-inch disk, it is akin to this hole right here. This is the index hole. But unlike on 5 1/4-inch discs, the index hole on the 8-inch discs actually moves around depending on the type of disk it is. So right here I have another 8-inch disc. This is one I used for the TRS-80 Model 2, and this is an IBM disc, and it doesn't really say too much about it here other than diskette 128 bytes per sector. To be honest, the bytes per sector doesn't really mean anything. This is a soft sector disk, which means the format of the disk is determined by the controller, so there could be an arbitrary number of sectors or bytes per sector. Either way, though, I know this is a single-sided disk, and if we slide this out, notice where the position of the index hole is. With them both visible at the same time, notice they are not in the same position. That means if I try to take this disk right here, this double-sided disk, and put it in a single-sided disk drive, like on the TRS-80 Model 2, it won't even be able to read the disk at all. Pulse that comes from the sensor that reads the index hole is absolutely necessary to synchronize the disk controller with the spinning diskette, and without the hole there, it's not going to be able to read it, and therefore it's not going to work. The Shugart SA800 drive that's in my TRS-80 Model 2 can only read single-sided disks because it only has one sensor, and it's in the position for reading these single-sided disks. If I put this other disk in there, it's not going to be able to read that at all. There's really no way for me to make it work other than perhaps taking a hole punch and lifting up the jacket there and trying to punch a hole in the actual outside jacket of the disk so that it could read that sensor. Anyhow, going back to these disks here, okay, so we know this is a CPM86 boot disk, and luckily it totally works. Luckily, 8-inch disks are extremely reliable. The large physical size of the media seems to mean that they're okay to spin all the time, because remember, that's what they do in those drives, but also they're just very, very robust. I'm not saying that discs like this never go bad, but up until this point, I've never actually run into a disk that's not working properly. So the next disk here is MS-DOS 211, and someone wrote DBase Rev A Original on here. Next disk here is a 3M double-sided, double-density disk, and it's MS-DOS version 211, volume 1B1, and it says Practice on there, whatever that is. And it looks like it is double-sided according to the little index hole there, which of course matches the sticker right here. Next disk here, and I'm starting to see a pattern. I'm wondering if the white labels are all going to be CPM86, the ones that are from NEC themselves. And the peach labels here, maybe these are all MS-DOS, at least the ones that come from NEC. So this disk here just says CPM86 Program Development Aids, and it says original on it as well. Because I think I'm missing the sleeve for this disk, I'm just going to double them up in there. All right, here's another one with a peach label, and look, it is MS-DOS as well. Also, MS-DOS WordStar, SpellStar, Mail Merge Original, type CDWP. All right, next up I have these two things here, which are the magnetic protection sheets for the disk drives, and they're just pieces of cardboard with a hole cut out in them, so there's really nothing special about these. If you want to make your own, just make it the size of a diskette. Okay, next disk here, we have another double-sided 3M here, and this is CPM System Disk, Basic, Graphics, and M. It actually has a date of 7/4/1993? What? Next up here, Basic Working Disk, Personal Basic, version 1.1, 1983. All right, here's a disk that says Sorcam Superware, and it's SuperCalc 2 for CPM 86. It says right here, this is designed specifically for the NEC APC. So there you go, specific software. Is there a date on here somewhere? 1983 right there. All right, the next disc, which is peach colored, is CPM 86. So obviously the peach color label has nothing to do with anything. DBase 2, CPM 86 by Ashton Tate. Do not duplicate. All right, now we have a couple discs inside of like an original Nippon Electric Company disc box carrier thing. Let's see, these appear to be original digital research discs. Personal Basic for CPM 86. This is obviously specifically for this machine. And this one is probably an OS disc. No, this is Personal Basic 1.0, old version someone wrote on it. So 1.1 and 1.0. Okay, next up, the Desmet DC88 Utilities, whatever that is, from Seaware, Paso Robles, California, side 1. And this is a single-sided, single-density reversible disc. Ooh, take a look at this. So the index holes here are in the position for the single-sided disc, but there's actually 2 punched. So this is actually a double-sided disc in here, and then you can flip it over, and when you do that, the index hole is going to be in the right position. Now, this is actually funny because when you think about it, these discs can't normally be flipped over. I'm talking about 5 1/4 inch discs. But machines where you typically did flip it over, like the Commodores and Apple IIs and Ataris, they don't use the index hole on here. So when you flip it over, the fact that it's in the wrong space, it doesn't matter because the index hole is not used. But on a single-sided PC disk drive, like on the original 5150, you can't just flip these over. Now, I've actually seen some discs, and I know I have some in the basement somewhere, that have 2 index holes on the 5 1/4 inch disc, so they can become flippy discs as well, which is exactly what's happening on this disc right here. Anyhow, I have no idea what this particular disc is or what this utility is, but it looks like there's another one here, and it says Desmet C Development System. So as a C Programming Languages, C Corporation, 1987. All right, this disc here is another from Sourcem, and it's another SuperCalc disc. It's probably a copy. It also has a 1993 on there. And someone printed out this, which is a list of the commands or whatever that's on there. And these CMD files right here indicate that this is CPM86 because it is COM on MS-DOS, of course. And if we take a look at this disk, it has the single index hole in the position for single-sided disks, and here's a double-sided drive disk over here, and even though these are lined up, it's over to the right a little bit. Okay, here's a double-sided double-density disk, and a copy. There's some writing here, and it's just barely visible. Something 2.11, 1993. I'm going to say that this maybe is an MS-DOS disk, so we'll stick that in the DOS pile. B copy, it says DOS right there, so we'll stick that in the pile. MS-DOS again. Looks like maybe this had WordStar on here at one point. Island, Kit, Prime.anc. All right, and the next one here is this C-Lang here, that Desmet software working disk with source files. MS-DOS there, 1993, but then CPM86 over here. We have a copy here of DBase, CPM 1.1. Okay, this disk here, DBase 2, CPM86, has a 1993 date on there again. All right, this one looks like CPM. Look at this, someone wrote CPM BIOS, return to stack SQL segments or something. So some software development was going on this machine, obviously. Look at this one. This is a copy of the CPM program development disk, Bad Sectors. So something happened to this disk. Interesting. All right, this verbatim disk here has a copy of Personal Basic, which obviously is a CPM software. And this is the last one here. An NEC floppy disk here, library name, code name, equipment name, APC, test 82. Is this some type of diagnostic disk? So after all that sorting, we're left with 2 piles, MS-DOS disks and CPM disks, plus a bunch that are unlabeled. I'm just going to go give these all a try inside the NEC APC and see if there's anything interesting on all of these disks. And unfortunately, after going through all those disks, I really didn't find anything particularly interesting. Outside of the regular 2 operating systems that we already saw the disks for, there was a development suite here for the C programming language, and this is for MS-DOS. This doesn't seem to be archived anywhere on the internet, so I will definitely be archiving these disks. But I don't really find any evidence of whatever was actually being developed with this software on any of these disks. There were actually a bunch of blank disks. They didn't have any labels on them, but there was actually nothing on any of them. Almost all of them were just formatted for MS-DOS and contained no files, or maybe were just a backup of one of these other floppy disks, and that was it. Since software development is pretty much the furthest thing from my wheelhouse at this point in my life, trying to develop some software for this using either assembly language or the C compiler here is not something I'm really going to do. But that doesn't mean that this video is over. There's actually some stuff I still want to try with this machine before we end this video. First up, let me get an 8-inch disk drive hooked up to the IBM PC because there's a couple things I want to try. First off is I want to archive these disks here, and I'll do that on that system. But then I want to see if DOS disks that are for this machine, like this MS-DOS boot disk right here, can actually be read and written to on a regular MS-DOS computer that's IBM PC compatible. There is no technical reason why an IBM PC couldn't read and write one of these disks made for this machine. An 8-inch disk like this has the same physical characteristics as a 5¼ inch, 1.2 megabyte high-density drive. I've talked about that a little bit in the past, but the high-density drive that's in the 5170 right here is just a shrunk-down version of the double-sided 8-inch disk drive that's in this machine. Let's switch over to the Workbench and get started reading and writing from these disks. All right, so I have a Cume double-sided 8-inch disk drive here on the bench, ready to go. It's connected up through a 50-pin cable through an adapter, which I bought on eBay a while back that goes from 50-pin to 34-pin. For this type of configuration, you can use any floppy controller, but I am using one that Kevin at TechSelect made, and it's kind of a special model designed for working with these 8-inch drives because it has a microcontroller on it and it counts up the tracks and it generates the TG43 signal. That TG43 signal, which I have routed through the cable all the way to the drive, is used to change the write current while you're writing disks. Some 8-inch drives require it and some don't. The previous video I did on 8-inch disk drives, which I'll link down below, that drive didn't need TG43, so I didn't even need to worry about that, but this drive does. So that's why I'm using his pre-release controller. That's unfortunately not available for sale yet, I don't think. If it is, I'll put a link in the description below. If not, well, I'll update the video in the future when he does have that for sale. If you have an 8-inch disk drive and you're not sure if it's single or double-sided, well, the easiest way to tell is just look right here and you can see the top head that reads the top side of the disk. On a single-sided drive, the head's on the bottom only and there'll be a felt pad up here. I wanted to point this out on this Cume double-sided drive. There are two index hole sensors right here. These are the LEDs on the top side, and on the underside is the actual receiver sensor. That means that this drive can read and write to both single-sided and double-sided drives because it has these two position sensors. To power up the 8-inch disk drive, I'm going to be using my two bench power supplies. This one's set for 5 volts at 1 amp, and this one here is set for 24 volts at 1 amp as well. And I'm going to hit this power strip here, which turns on the AC spindle motor, so that drive is spinning now. And then I'm just going to turn on this PC, and here it goes. One other thing I want to point out about these drives, at least this one, it's very difficult to get in between the heads if you're trying to clean them manually. So I'm very grateful that sometime in the past, someone gave me this Radio Shack 8-inch universal disk drive head cleaning kit. The amusing thing is when I originally got this, I never really thought I'd ever have a Model 2 or any 8-inch disk drives for that matter. So I was sort of on the fence of giving this away to someone else or keeping it, and I'm really glad that I did keep it because inside here are a couple discs. These are the cleaning discs itself, and yes, it does come with 2 in the kit. And the reason why is one of them is configured for double-sided, so you can see the white material there, and there's the backside. And the other disc is configured for single-sided because it has a little plastic cover on there. You don't want to be sticking a double-sided cleaning disc into a single-sided drive because that felt pad that normally pushes down on the disc probably shouldn't be rubbing against this abrasive cleaning material here. Okay, I'm going to be using ImageDisk, the great DOS program that's extremely useful for imaging these disks and also doing a little bit of analysis on them. All I need to do is set it for 77 tracks, double-sided, and single step is off. I just push this button to open the mechanism. Clunk. Let's slide in this DOS disk here. This is the DOS 2.11 disk. Close that down. And then on IMD, I'm going to push A for alignment. And let's take a look at the format of that first track. It's doing the analysis. Okay, 500 kilobits per second, double density, 8 sectors of 1K each. So that is definitely a little bit different than high density disks on the PC. There's something like, I think they're 19 sectors per track or maybe 18 sectors per track, and I think 512 bytes. So unfortunately to me, that doesn't bode well that this is actually going to read properly in here. I exited out of IMD because I want to try to read this disk in DOS here. But the thing you have to consider or remember when using IMD is you really, really need to reboot the computer after running IMD because it directly manipulates the drive controller and it usually leaves it in a state that DOS is not happy with. And DOS won't read any disk after IMD's been running. At least that's been my experience. All right, so the computer's rebooted. Let's go to A and see if it works. It doesn't sound like it's happy. It's sort of jumping back and forth here. No. Okay, sector not found. So that's a definite no. So I gotta say, that's a real bummer. I was actually really hoping that we'd just be able to read these disks, copy some files onto it, and then put them back in the APC so I could see if any programs designed for the original 5150 actually worked on this thing. Things that, of course, didn't directly interface to the hardware. There's actually one more thing I want to try to make sure that we can't get files from a regular PC over to the NEC. And I'm going to take a double-sided 8-inch disc like this one, and I'm going to format it using NFormat here. And specifically NFormat, it just creates regular DOS formatted disks, but it allows us to specify the parameters. And remember that this drive is only 77 tracks, and if we try to use regular MS-DOS format, it's going to try to use all 80 tracks, which we know is not going to work. So let's format this as a regular DOS disk, copy a few files onto it, and then see if the NEC can actually read it. Incidentally, there's another physical characteristic of these 8-inch disks which I haven't talked about. Other than the fact that there's the different size index hole or different position, there's actually a write protect notch on some of these. But unlike on a 5¼ inch, when this is actually taped over, that means the drive can actually write to the disk, and I'd have to peel the sticker off and have a notch there, and then the drive would actually be write protected. It's the reverse of 5¼ inch. And I think the reason it's like that is because early 8-inch drives didn't even have a sensor to tell if it was write protected or not. So the disks were just completely solid along the bottom row there. So when they finally added a sensor, they didn't want you to have to notch your disks to even get them to write in your drive. You notched it to make it write protected. So just a little bit of an interesting factoid. Let's slide this disk in here. I don't actually know for sure if this is a good disk, but we'll find out very soon. Let's just format it. It's going to be 1.15 megabytes inside, size that is, and here it goes. And there it is. The disk is formatted. That absolutely worked. So if we exit out of this and we look at the A drive, we should have nothing on there. Check disk A, 1,167,000 bytes free disk space. Which is odd because earlier in the video we ran check disk on the APC and it had more free space than this thing does. I wonder if that's because the sector size, which we saw on IMD, was 1024 bytes, and I'm pretty sure with MS-DOS on a PC like this, it's only 512 bytes. So some more space is wasted in the gaps in between the sectors, probably causing some space loss. Let's copy NFormat onto this drive here, and that's what we're going to test with. All right, the APC is booted and the disk is in the second drive. Let's go to B and do dir. And it does not appear like it's going to work. Generally, disk access on this machine is extremely fast. Read fault error in drive B. That sucks. Now, unless there's a program on either one of these computers that can allow it to read disks from the other machine, I think the hopes of getting any MS-DOS programs onto this thing are pretty much dashed. But on the other hand, I think there's a way to at least read and write the CP/M disks from that machine. There is the old DOS program called 22disk, and this program is specifically designed to read and write from the CP/M disks of many machines. In fact, here's the program running on the machine, and if we go to set type and we hit enter for the list, here is the list of stuff that this thing can actually support, and it's quite extensive. The big board, I mean, there's just Coleco Atom, CompuPro, tons and tons of stuff. And of course, for some machines like the TRS-80, there's actually multiple different types of CP/M that can run on that thing. And if we get down to there, oh, incidentally, there's IBM PC CP/M86, double-sided and single-sided discs, so it supports even CP/M86 there. It supports a whole bunch of NEC machines, as you can see there, including this particular one, and there is CP/M86 right there in the middle, DSHD. It calls it high density, even though it's not really. But if we keep scrolling down through the list here, Olivetti M20, Osborne, Philips, blah, 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 tons and tons of machines. It's just awesome how many things this thing supports. Eventually we'll get to TRS-80, and there they are, Model 4, 4P, and there are various CP/M versions that run, like Lifeboat, the Pickles and Trout, Holmes, Hurricane, Montezuma. There's just like a bunch of different types there, so it's pretty cool, it supports it. And yes, it also supports the CP/Ms that run on the Model 2 as well, because the Model 2 can run either TRS-DOS or CP/M. Unfortunately, though, this thing, while it's seemingly physically able to read all these types of disks, it doesn't read the MS-DOS disks on this machine, just like it doesn't read the TRS-DOS disks for the TRS-80. this software really only supports CP/M. So there it is, it's set for NEC APC. And here's a CP/M86 disk for that machine. It seems like it's the one that just has a bunch of random stuff on it. And I did look at it, and indeed that's what it has, just random stuff. And now we have to do display a directory 6, and we can enter a wildcard. We're not gonna do that. Hit enter. There it is. That's the stuff that's on this disk. I have a copy of the CP/M86 version of Zork on the compact flash card on this computer. So we go to 4 for copy. I think that is the path to Zork 1 there. We hit enter, destination name. I think I don't specify anything here. I'm just gonna hit enter. And I think it's copy. Now there wasn't enough space on this disk for all 3 versions of Zork, which I have. So we're just gonna copy Zork 1. And it's going. It's making lots of noise, but I think this should work. Maybe. I haven't actually tested this yet. All right, it's done. 84K remaining. Let's move that disk over. All righty, here we are booted up. Let's go to the B drive. Look at what's on here. Just some random stuff, but there's Zork 1 command and Zork1.dat. Zork 1, let's see what happens. This is designed to run on CP/M86 on the regular MS-DOS computers. And there we have it, Zork 1, the Great Underground Empire. And look, it even supports the correct reverse status bar up at the top here. Oh, there's actually a problem. I can't type anything. It is maybe talking directly to the keyboard or something. Let's see if I hit Control Break Stop. That doesn't even exit out. So I guess this Zork interpreter must try to talk directly to the keyboard controller on the regular IBM PC, which is not compatible with this machine. So even this doesn't work properly. But I guess they just assumed that the only CP/M86 machine that this would run on was on an IBM PC, so they didn't even bother making it work properly on anything else. That is sad. So I'm gonna hit the old Control-Alt-Delete or Control Function Break Stop to reboot this machine because there was no other way to break out of that. And just in case that was some kind of a fluke, I'm gonna do it one more time just to double check. Zork 1. That seemed weird that the keyboard just didn't work. And there it is. And yep, absolutely no functionality of any key on the keyboard at all. Bummer. Off camera, I went ahead and I imaged all the floppy disks that were for this machine on the setup over there using IMD. I'm gonna upload the C compiler thing to archive.org. Of course, I'll put a link in the description below. I actually found on BitSavers they had several pieces of software for this machine archived, along with a bunch of manuals. But the stuff they had on there was pretty much just the stuff I already had, like WordStar, the operating system disks. I think they had also like a graphing program that probably requires the graphics adapter. Nothing really particularly interesting up there. And they didn't have that C compiler environment. So hopefully someone can let them know that I've uploaded that to archive.org and they can maybe merge that into their collection. BitSavers had PDFs of several of the manuals for this, but I actually have some of the manuals that they don't have. So I'll also scan those and put a link in the description below, so maybe they can merge those into their collection as well. So what do I think about this machine? I'm very disappointed that it can't read or write DOS disks from the PC. I don't really understand why it should work, and yet they both can't read each other's disks. And then to make things worse, that CP/M86 program didn't work either. That might just be Zork that doesn't work, and there might be other things that do work, but unfortunately CP/M86 barely had any software on it because by the time it came out for the PC, MS-DOS was really taking off, and people didn't really see a need to port stuff to CP/M86. The old version of CP/M, which is for the Z80, has tons and tons of software, but even though CP/M stuff is cross-compatible between machines, a lot of times, it has to at least be the same architecture. So you can't run Z80 CP/M software on a machine with an 8086. You have to run 8086 code, even though it's CP/M operating system. Now, the computer itself is such a well-built, really awesome computer. I feel like if I were shopping for computers in 1982, I might have bought one of these as well, because when you're cross-shopping like an IBM PC5150 with the disk drives and the monitor and keyboard, I think it was very similar in price to this. And when you compare the features, this computer is substantially better. 16-bit processor, actually with 16-bit memory, so there should be a lot more speed there. incredibly high resolution screen compared to like CGA, for instance. And then of course you have these really high capacity disk drives. The version of this with color, which I haven't tried out, has the similarly high resolution screen, and if you have 2 graphics board, you're gonna get 640 by 475 graphics in 8 colors, which is pretty mind-blowing. It took until EGA before that was pretty common on the PC, so this thing was really ahead of its time. I think in 1982, when you're doing that cross-shopping, you wouldn't have really known that it was this machine that would fail so miserably in the software department, while the IBM PC would just take off with, you know, billions and billions of pieces of software written for it. And yeah, this thing, it just sort of was relegated to the scrap heap, basically. By the time NEC released the 4th iteration of this, they just gave up on the entire architecture and switched over to being an IBM PC compatible, pretty much like everything else did. It really does make me a little sad that as cool as this machine is, all we really have for it are a couple operating systems and several business applications, and that's pretty much it. Although, there's actually one thing you can do on this machine which you can't do on the regular IBM PC 5150, and is actually something that Commodore fans will know a lot about. Let me demonstrate. Here I am booted up into CP/M, and if I run the command disp1, which we've looked at on the MS-DOS disk, this just shows the built-in character set in the ROM on this board. And take a look right here. Notice these characters that look like a slash and a backslash are right next to each other. That is different than the normal ASCII slash and backslash, which are not near each other. And when they're next to each other like this, that enables one specific thing. I've gone ahead and I entered Personal Basic, which is made by Digital Research. There's a little trivia here that another computer from the 80s that also uses BASIC made by Digital Research is the TI-99, or at least I think it is. And the reason why I think that connection is there is that because with this BASIC, to load a program that you previously typed in and saved, you use the command OLD. And right here is the program I just loaded off the B drive. And if you're a Commodore fan, you're gonna know exactly what this does. And when we run it, there it is, a one-line maze program. And it looks freaking great. Now on the Commodore, this works from the Commodore PET all the way up, because anything that uses PETSCII happens to have the type of characters next to each other that allow you to use that random command to basically use a random number added to a character to print either of them. Incidentally, the little bit of flickering that you're seeing here is from the refresh rate of a monitor, which I do not see with my own eyes, but I can tell in the camera it's flickering a little bit. So I apologize about that. Anyhow, if you're aware of any other machine that with the default character set you can run a one-line maze generator program, definitely post in the comments below. Because I've looked at various character sets on other machines and I've never found any other machine besides the Commodore and now the NEC APC that can actually do this. So that is the NEC APC, a machine that had a lot going for it that was let down by the fact that hardly any software was written for it. When the IBM PC came out in 1981, this machine, along with some others like the HP 150, came out to directly compete against IBM in that same exact market space using the same processor or similar processor. And as we all know the story, IBM completely won out, specifically because the clones came and that just wiped out every other cool machine like this. So all that's left are these old relics like this that unfortunately can't do as much as they probably could. So that's it. If you want me to do anything else with this machine, let me know in the comment section below. I think that's going to be it for this series, just 2 parts if you can believe it. So if you like this video, thumbs up. But if you didn't, you know what to do. And put your comments down below, of course. Hit that subscribe button. Huge thanks to my patrons. Their names are scrolling up the side of the screen over here. I want to thank them for everything they do to support me in the basement here. It really makes a big difference to me. So if you want to become a patron, get early access videos, all that good stuff, you can do so at the link in the description below. Check out the second channel, you know, all that usual YouTube-y stuff. And that's going to be that. So stay healthy, stay safe. I will see you next time. Bye.